This lesson is over powers and exponents. So before we do that, let's look at our number routine. Is this in the correct order from L to G or least to greatest? So I see all these rational numbers. All right, first of all, what do you prefer? Do you prefer decimals, fractions, or percents? I like percents. So negative 75%. This would be negative 23 hundredths, and again, hundredths means a percent means per 100, so that'd be negative 23%. Well, zero definitely would be 0%. 2/5. How do you build this up per 100? Times 20 times 20, so that's 40 hundredths or 40%. So I think it's already in least to greatest. Negative 75% is the least, then negative 23%, 0%, 40%, 45%. So this is in order from least to greatest. So let's look at our do now. Carol spends 18 hours in a 3-week period practicing her culinary skills. How many hours does she practice in 5 weeks? Do you prefer proportion or making a table? I'm going to make a table because I think that's easier. So here's our table. This is about hours. This is about weeks. So she spends 18 hours in 3-week period. How many hours does she spend in a 5-week period? So if 5 goes here. Can 3 go into 5? I don't think so. Let's look at the up and down method. Can 3 go into 18? Yes, it can. Times 6. So if I times 6 here, this is times 6. So the answer is 30 hours in a 5-week period. Another way I could have done it is I could have simplified 18 and 3, divide both numbers by 3, and get 6 hours per week, then build it up by a scale factor of 5. So 6 times 5 is 30. So, introduction lesson today. Do you get an allowance? If so, how much do you get per week, each week? When I was a kid, I never got an allowance. It's pretty much my parents got me what I needed and the bare essentials, and that's it. If I wanted anything fancy, I would have to make sure I got some good grades or done a good job in life. So there's a girl named Lori. She suggested that her allowance be changed. She wanted 2 cents the first week. Wow. With her allowance to be doubled each week. Do you think her parents will agree with her suggestion? Well, as a parent, I was like, she just wants 2 weeks, 2 cents for the first week, and then next week 4 cents. I think that's a pretty good deal. I honestly think so. But let's do the mathematics just to make sure, because as a math teacher, I would have liked to make sure I got all my x's and zeros in a row. So in week 1, she gets 2 cents. In week 2, she gets 4 cents because we doubled that amount. In week 3, she gets 8 cents. In week 4, so we copy week 3, and we double that amount. So 2 times 2 is 4, times 2 is 8, times 2 is 16 cents. So in week 5, we get 2 times 2 times 2 times 2 times 2. That would equal, double that, 32 cents. You know what? This is a really good deal. So in 5 weeks, you only get 32 cents. Week 6, she gets 2 cents the first week. We double that the second week. We double that the third week. We double that the fourth week. We double that the 5th week. Now we double it the 6th week. So if we double that, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2, 32, times 2 is 64 cents. Now this is a sweet deal. For the parents so far, week 7, 2 cents the first week, 2 cents the second week, 2 cents the third week, 2 cents the fourth week, 2 cents the fifth week, 2 cents the sixth week, and 2 cents the seventh week. If we double that, that'll be 128 cents, which is really $1.28. Uh-oh. So I'm not going to keep on writing these twos. If I double that, that would be $2 and I believe 56 cents. If I double this, let's see, double is 12 carry to 1, is 11 carry to 1. I believe is, wait, nope. Where's my eraser? This, I believe, is 512. Eraser, oh, here it is. Let's do that again. Let's get my calligraphy pen. So let's see. Double 56, that's 12, carry on, carry 5. Double it, $5.12. And then I've doubled that. Again, that'll be $10.24. So, from what I can tell, for the parent, it's actually a very good deal. Until you reach about maybe the 9th or 10th week. But then it rapidly increases because by 2, you're doubling it. So on the 11th week, that would be almost like $10 and $20.48. And so I think the parents should just cap it at the 10th week. And then Lauren, or whoever the girl name is, will be very unhappy. So did you get bored writing out all those time signs? I did. You see, I stopped and I just started doing the mathematics. Is there a shorthand shortcut for multiplying the same number by itself several times? There is. It is called exponents. Exponents show repeated multiplication. You know how multiplication is repeated addition, but exponent is really repeated multiplication. So instead of writing 3 times 3 times 3 times 3, we can write it as a shorthand as 3 to the power of 4. 3 is the base, 4 is the exponent. This 4 tells you how many times you're going to multiply 3 over and over and over. So 3 is the base, that's the number we're going to be using. And we're going to multiply 4 by itself 4 times. That's why we write out the number 3 4 times. Do not do this. I see so many kids, and I watch other YouTube videos, and actually kids have noted in their video too, do not multiply the base and the exponent and say, oh, 3 times 4 is 12. That is not. If 3 times 4 is 12, wouldn't we have just written it as this way? 3 times 4 is 12. Why would we have to go all to this fancy notation with exponents? So this is 3 to the 4th power. The base is 3. The exponent is 4. You write the number 3, 4, write it itself 4 times. So we can say this as the 3 to the 4th power. That's how I say it. Some people say 3 exponent 4. Some people say the 4th power of 3. Whatever you want to say in this one. So when you have a 2 and a 3 though, some people say this as 3 to the power of 2 or 3 to the power of 3. However, the more mathematical way of saying it is 3 squared and 3 cubed. When you see a 2 as the exponent, we say squared. If you see a 3, you say cube. You may say, but why? Think about it. If it's 2-dimensional, it is a flat surface. It's 2D. When something is 3-dimensional, such as this cubed, then it is cubed. So that's how I memorize it. I don't know, this is what 2-dimensional is squared. A three-dimensional shape is cubed. Because in science, in math, and when you learn about area of a square or rectangle, you multiply the length and the width, or the base and the height. In volume, when you do a cube, to find a volume, you multiply the length, the width, and the height, which makes a cube. So, what is the value of 3 to the power of 0, or 3 exponent 0? Some people say it's 1. Some people say it was 3. Some people even may say it's 1. So what's the value? Well, let's justify what you think it is. 3 to the power 1 is 3. 3 squared, 3 times 3 is 9. 3 cubed, 3 times 3 times 3 is 27. 3 to the 4th power is 3 times 3 times 3 times 3 is 81. And 3 to the 5th power is 3 times 3 times 3 times 3 times 3 is 243. So if you said the exponent is 0, well, that makes sense. If you multiply numbers by 0, how would you get 3, 9, 27, 81, 243? If you said the answer is 3, no, it's not, because 3 to the 1st power is 3. The answer is actually 1. Anything to the exponent of 0 will always be 1, because we start with a pattern with the number 1. Then you multiply that by a 3, hence you get 3. Then you multiply by 3, you get a 9. You can continue the pattern. So I, Mr. Joe, to the power of 0, I am number 1. So anything to the power of 0, you're number 1. So let's practice some questions. Generate an equivalent expression using an exponent. So how would you write this as an exponent? Because I do not want to write this as repeated addition. It's just shorthand. 7 is the base. The exponent is 2, or 7 squared. 12 is the base. The exponent is 3. 12 cubed. 1 4/10 is the base. The exponent is 1, 2, 3, 4, 5. Next one. 1/3 is the base. The exponent is 4, because it's repeating itself, multiplying itself 4 times. Now let's think backward. Express each power or exponent as a product of the same factor. Find its value. 19 is the base. It repeats 1. I'm done. 8 is the base. It repeats twice, because the exponent is 2. So what is 8 times 8? 64. I notice a lot of kids, over my years of teaching, kids are so ingrained with addition, they'll say, oh, 8 times 8 is 16. And then said, are you adding or multiplying? Then they'll say, oh, yeah, 8 times 8 is 64. Next one, 5 to the 4th power. 5 is the base, so it repeats itself 4 times. So what do you get when you multiply this? Many ways to solve this. You can multiply 5 times 5 is 25, times 5 is 125, times 5 is, I believe, 625. Or you could do it this way. 5 times 5 is 25. So you're multiplying pairs of number. This 5 times 5 is 25, and 25 times 25 is 625. What about this one? 1 3/10 is the base. 1 3/10, it repeats itself 3 times. So what do you get when you multiply? Well, 1 3/10 times 1 3/10 is 1 69 hundredths. I'm going to multiply that by 1 3/10. So that's 27, carry the 2, 18 plus 2, carry the 2, 18 plus 2 is 20, carry the 2, that's a 0 by the way, and that's 3 plus 2 is 5. Placeholder, 9, 6, 1. This adds up to 7, 9, 11, carry the 1. And there are 3 numbers behind the digits. So it's 2 and 197 thousandths. Next one, the base is 1/4. You're going to multiply this 3 times. So what do you get when you multiply 1 times 1 times 1? 1. What do you get when you multiply 4 times 4? 16 times 4 is 64. So the fraction is 1/64. And last but not least, we have 3 squared. That's 3 times 3 is 9. And then we have 6 squared. 6 times 6 is 36. This will add up to 45, I believe. Last but not least, what's 3 squared? 9, because 3 times 3 is 9. Times, what's 5 squared? 5 repeats itself twice. So 5 times 5 is 25. So 9 groups of 25 is 45 carried to 4, 225. And so pretty much what we did is we practiced with exponent. You have the base and the exponent. The base is the number that you're going to be multiplying with, the factor you're going to multiply with. The exponent tells you how many times you're going to multiply that factor by itself. And let's practice 2 more questions before we finish. Tamika delivered 50 square newspaper last summer. Express 50 square as a product of the same factor, then determine the value. So 50 is the base. This factor repeats itself twice. So 50 times 5, let's see, 5 times 5 is 25, 20 fall, so it's 2,500. And one of the world's smallest country, Vatican City, has a population less than 10 cubed. How many people live in this country? If you don't know, some of you may have gone there. Vatican is in the heart of Rome. Hopefully I will be able to go there this summer. We'll see. So 10 cubed, 10 is a base. It repeats itself 3 times. So 10 times 10, that's 1. 1 times 1 times 1 is 1. 3 zeros follow it, so it's 1,000. And this is the study of powers and exponents.